Good evening and welcome to Good Earth News, everyone, on this, the fourth night of Pint of Science 2021. Tonight, it's not all doom and gloom. In a welcome break from 2021, we're taking an hour of your time to celebrate some of the positive headlines and good news stories about the environment that are both close to home here in very rainy Leicester and around the world. But before I introduce myself and the wonderful speakers we've got set up for you tonight, we'd like to get to know you. If you can comment in the comment section to my right, to my left, down below me, wherever it is, both where you're from, we'd love to hear about that. But more importantly, your relationship with science. Are you a 6 o'clock news watcher, an avid Twitter follower, a non-fiction book junkie, working in it like us for a living? Or is it just my parents out there here for some emotional support? I'm your host for the next hour, Chris Stockey, and by day, I'm a PhD student researching how climate change affect food webs within the sea using fossils hundreds of millions of years ago. But tonight, I do have the pleasure of being your host. I can see loads of people kicking off in the comments from Brixton, Jelly Shore, Norwich, and Hull as well. I even saw earlier some people from overseas across the pond in America. Welcome all. And Sue Davis, a fellow academic up in Nottingham, is there. And people even saying hello to my mum, which is a fun one. Hi, mum. And really nice to see a lot of people, both STEM educators, parts of the NASA outreach program. That's an incredible job. And others tuning in from around the world. And it's lovely to have you here with us. But like I said, tonight is all about two fantastic researchers who will be talking to you about their respective fields, and then I will be joining them for a panel discussion in the third half of our show. To talk to you about both the research that's being presented to you tonight, as well as answer any of your questions that you have about the environment, past, present, and future. So please put them in the comments section whenever they come to you throughout the presentations. Any burning questions that you've wanted to scream at the news for the last year and a half, preferably about the environment, put them there and we'll make sure to come back to them in the second half of the show. Can see a few more people commenting. Zurich as well. Hello, it's lovely to hear from you. And Hannah Sellers, somebody else from Leicester starting a PhD. Wonderful. So with that, it is time to head to the main event and introduce our first speaker. Here to tell us all about conservation and rewilding efforts. They're a postdoctoral researcher of nature management and re-establishments of megafauna at the University of Leicester. It's Pil Pedersen.
Thank you, Chris, and thank you to the organisers of this Pint of Science event in Leicester. I originally thought I was invited because of my financial supporter, Carlsberg Foundation, who earns all the money from brewing Carlsberg beers and selling them. But I'm assured that that's not the case, and it's actually because someone thinks I have a positive story to tell from my research. But I will start off by sharing this rather powerful cartoon by McKay, just to remind us all that we need to see this pandemic into a broader perspective, and also remind us about that we need to think smart, and we need to find smart solutions to the challenges that are ahead of us. Because in 1992, the EU launched a conservation policy, namely the Nature's Directives, so the Habitat Directives and the Birds Directive. And the idea behind these directives was to stop the loss of biodiversity in the EU. And the idea of the directives was to protect valuable habitats and valuable species. As a result of these policies, really the focus of conservation efforts in Europe has been on habitat conservation, so conserving specific habitats in the EU, and also species conservation, so protecting, conserving, obtaining a viable population of a certain target species. And though UK is not any longer part of the EU. This is very much the backbone of conservation efforts in UK. But recently, another conservation strategy had come, namely rewilding. And rewilding is different from the two other conservation efforts in that it focuses not on habitats or species, but on processes. The aim of rewilding is to create more biodiverse, self-regulating ecosystems, really. A particular type of rewilding is called trophic rewilding, and that focuses on restoring trophic interactions between species at different trophic levels and also the associated trophic cascades. And it does that often by reintroducing large herbivores, mega herbivores, or other apex consumers. It could also be predators. So let's take an example. I guess here in UK, quite a lot of people would have heard about rewilding in relation to beaver reintroductions. And we see quite a lot of beaver reintroduction across UK at the moment. But beaver reintroduction can also be considered as species conservation. Because beavers have been extinct regionally here from the British Isles since the 16th century. Beaver reintroductions can also be looked at as habitat conservation if the focus of reintroducing beavers is to create certain. So as you can see here, rewilding is not necessarily competitive to the two other traditional strategies of conservation. It should be seen more as and complements the two. The key arguments for trophic rewilding is one, the size differential defaunation that we have experienced throughout the last long time. So what we can see in this graph is in the top panel that the species that are extinct in the Pleistocene are larger than the ones that have gone extinct here in the Anthropocene in the current geological period. And again, those are larger than the ones that are just in today. And again, they are larger than the ones that are non-threatened. So really what this graph shows is that the larger you are, the more likely you are to go extinct. The second key argument for trophic rewilding is that we are seeing increasing evidence of apex consumers of mega herbivores, large herbivores, predators being really important for the ecosystem. If you look here at panel C, you see the classical rewilding, Yellowstone National Park, where wolves were reintroduced after 70 years of absence. And what you can see in the first picture is before the wolf was reintroduced, and then the picture afterward is after the wolf has been reintroduced. And you can see the difference in the regeneration of trees and shrubs down by the river. And that's because the presence of the wolves changed the behavior of the deers. So when the wolves were present, the deers were less likely to browse and graze down by the river because they're more prone to predation down there. So that was the second argument for rewilding. Here we have tried to make a map of the global scope for rewilding. So on the left side, we have here the actual situation. So the current situation in today's ecosystems. So we have in the top panel the richness of megafauna, mega herbivores, and in the middle one for the large herbivores, and in the low one for carnivores. And then in the right panel, you see how it would have been if it wasn't for humans. So in the complete absence of humans, you see how many more species of these functional groups we would have had. So clearly for mega herbivores, we are missing a lot of species in the New World, but also in Europe. The same thing goes for large herbivores, and the same thing goes for carnivores. We can also see that the ecosystems in Africa and Southeast Asia is more intact than in the rest of the world. So that is a way to illustrate the need for rewilding. We can also look at it in a bit different way. So here's an artist's reconstruction of a landscape in South Wales, just to show you how many species that were back in the last interglacial, where we have similar climates as we have now. So here we would have seen spotted hyenas, hippos, straight elephants, rhinos, red deer, and fallow deers. Just to make it even more obvious, here's a list of species with red crosses. Those are the ones that are extinct now in northwestern Europe. Species belonging to the northwestern Europe. They're extinct now. The red crosses, the straight tusked Merck's rhino, woolly rhino, Caribbean giant deer, or Irish elk, as it's also called. Then with the red crosses, we have the regionally extinct species. Those are species that still exist and can be reintroduced. So here we have bison, wild boar, brown bear, moose, and beavers. And with orange crosses, we have the species where the wild type has gone extinct, so European wild horse and aurochs, but where we still have the domestic breeds and they can be reintroduced as well. And what is really left in our ecosystems that live freely is red deer, fallow deer, and roe deer. So you can see we are missing quite a lot of species in our ecosystems. And with the missing species, we also don't have the ecological functions of these species. What do I mean with ecological functions? I thought I should explain that a bit more, and I've chosen to do that with this beautiful reconstruction by Jeroen Helmer from Ark Nature in the Netherlands. So what you can see here is bison graze. They graze grasses and herbs, and by that they create different sward heights. They also browse on tree buds and shrub buds, so they reduce the tree growth and encroach. You might also debark trees and maybe even turn them over, so creating dead wood volumes. And by walking around, they disperse seeds that sit in their fur or comes with their dung. And they trample around in the landscape and they do sand bathing and create bare soil patches which provide habitat for species that could potentially colonize these patches. They have dung pellets that is habitat and food source for a lot of species, fungi and a suite of insects. And eventually when the individual die, that is also a really important habitat and food resource for scavengers and other species. So the ecological functions are really important here, and I think this nicely illustrates the whole idea behind rewilding, namely that by reintroducing these species back into the system, they provide lots of variation in the landscape and create habitat and food resources for other species that they have co-evolved with. So turning a bit more to climate change, with global warming, we are likely to see drought events in the future. And rewilding has also been hypothesized, argued to increase the resilience of ecosystems. So when we had the really severe drought in 2018, particularly severe was it in Denmark, where I come from, I thought that really provided a nice case for studying if that's actually the case. Is rewilding areas more climate resilient than normal protected areas? And we don't quite, I don't have the final results, but I'm showing you here. So what you see here is a map with the yellow outline of a Danish rewilding site called the Mons Laboratory. Behind you see images from the Sentinel-2 satellite. And in this rewilding area, we have, which is 120 hectares big, and we have highland cattle and export ponies in this area. There's very little human management. And to look into the climate resilience, we have laid out some plots. One plot in the rewilding area in green, one in red outside in a protected area, which is summer grazed, one gray box in protected area bone, and then in yellow we have a farm. And these are all as comparable as possible, these sites. So then by extracting data from satellites, we are looking into the resilience of these four systems. And what you can see here on the y-axis is that proxy for the healthiness of the vegetation, the change of healthiness in the vegetation, I should say. So the closer to zero, the smaller an impact the drought had on the ecosystem, and the further away from zero, a larger impact. As you can see here, turning towards the more natural ecosystems, we see a smaller impact of the drought, indicating that these systems are maybe more robust to the drought. Shown a bit different, same thing on the y-axis, so change in healthiness of vegetation, but now we can see it over more years. So we have the year before the drought, 17, and 2 years after the drought. And so here we get a sense of how quickly the systems bounces back from the drought impact. And again, what we see is the more natural the system is, going towards trophic rewilding, we see that the system seems to bounce more quickly back. And that's really interesting. And we are really excited to see the final results from this research project. Another thing that is going to happen with climate change is more heavy rainfall events. And here beavers are most likely going to play a really important role, as we are already seeing it across beaver projects in Europe. But I just wanted to show you here that showing ortho footage from a beaver site in Denmark, you can really get a feel of how much they changes the environment, the landscape. So 2014, we see no beaver dam. And 2 years after, we have already quite a big beaver dam and lots of water standing behind the dam. And then 2 years later, it's even bigger and a lot of water is standing behind it. So it gives you a sense of how much buffer capacity these beavers provide the ecosystems. Actually, UK researchers have looked into this. So they have, down in the Devon beaver trial, they have measured the flow of water coming in upstream to the beaver dam and then downstream of the beaver dam. And what you can see here in blue is the measurements upstream to the beaver dam, and then in red, downstream of the beaver dam. And you can clearly see that we don't see a peak downstream of the beaver dam. So this really shows the difference, what the beaver dam does to this landscape. And the study says that overall they found that peak discharges were reduced by 30%, and that really matters. And there are already cases across Europe, for example, from Bavaria and Germany, where villages are experiencing less flood risk now with beavers creating dams upstream. So that's really interesting. So I hope with this talk have told you a little about the positive potentials of rewilding, trophic rewilding, potentials of creating more biodiverse, rich ecosystems, and also creating resilient or have the potential to. So rewilding might help us in winding this coil back into a situation where the species can better support each other. And that's really it for me today. I would like to say thank you for support to the Carlsberg Foundation, and also thank you to everyone out there listening. Thank you.
Thank you so much, Pil, for a really interesting introduction to rewilding. And I can see that there are loads and loads of questions popping up in the chat, which we'll come to at the Q&A panel session. But I'm going to selfishly jump in first with a quick question before we move on. And it sounds like an amazing process. But is there somewhere that I can go in the UK to see rewilding today, or where's it going to be here?
Yeah, plenty of places you can go, Chris. So actually, there are really good resources to find out where to go in the UK. One can look up on the Rewilding Britain's webpage, or if you're more interested in beaver reintroductions, go to the Beaver Trust webpage. I can highly recommend going to see the Leicester State Rewilding project down south in England. But if you want to go somewhere more close to the Leicestershire, maybe go Cannons Hills in Norfolk. That's not too far away. That would be really interesting. And they have recently introduced a couple of beavers.
Okay, that's amazing. Thank you very much. And I think with that, it's time to move on to our second speaker. And it's a delight to introduce them. Here to tell us all about greenhouse gas emissions and monitoring, they're a postdoctoral researcher in Earth observation data, also at the University of Leicester. It's Cristina Ruiz Villena.
Hi, thanks Chris for the introduction. And thank you so much to everyone that's here today. I want to say a special thank you to all my friends and family that are tuning in from Spain today. It's been a long year of pandemic and we haven't seen each other, so this is a wonderful way to reconnect through science. So as Chris said, I'm a researcher at the University of Leicester and I work in the greenhouse gas group. And so what we do is we study greenhouse gases in the atmosphere using many different types of measurements. So today I will talk to you about our work using satellite observations of methane. So first of all, when I was preparing this talk, I asked my friends and family, what do you think of when you hear the word methane? And I have to say, I got some interesting responses. You can type your own in the chat if you like. So the first one I got was farts, fair enough. So the next one was cows. Then I got cow farts. Then some people said industry. And then, of course, there was my mom who said, of course, I think of you when I think of methane. Thanks, Mom. But now, jokes aside, what is methane and why does it matter? So methane is a gas and is made of 1 atom of carbon, 4 atoms of hydrogen, and it's very flammable. You won't be surprised if I tell you that natural gas is predominantly made of methane. So, but why are we interested in studying it? Is because it's a very potent greenhouse gas which causes climate change. So just let's refresh the greenhouse effect. So this is actually a natural effect, and what happens is the solar radiation travels through the atmosphere. Some of it gets reflected back into space, but some of it is absorbed by the Earth, and this energy is then re-emitted. Some of it goes back into space, but a lot of it is trapped by greenhouse gases that are present in the atmosphere. Now, these gases are present in very tiny amounts, but then they have quite a lot of potential for warming, and this is why we have a nice, comfortable temperature on our planet. Now, the problem is that since the Industrial Revolution, for the last couple of 100 years, we have been pumping loads of these greenhouse gases into the atmosphere, and we've kind of broken the balance of the Earth. So now the planet is warming to dangerous levels and causing climate change. So this is a table with the main greenhouse gases in the atmosphere. So the one that you probably are most familiar with is carbon dioxide, because it is the most important one. But actually methane is the second most important greenhouse gas, and its lifetime in the atmosphere is shorter than CO2. However, it's 84 times more potent in terms of its ability to retain heat if we consider a 20-year period. So this is why methane is so important. And other greenhouse gases include N2O, which is laughing gas, and also some fluorinated gases. But these, even though they're much more potent, they are in less amounts in the atmosphere. So some more facts about methane. It actually causes a quarter of all the global warming is caused by methane. The other 3/4 is mostly CO2 plus the other greenhouse gases. And the thing is, most of it is generated by us. So 60 to 70% is man-made. And for the last 200 years, the concentration in the atmosphere has almost tripled to very dangerous levels. Here you can see on the right, this plot, it shows the global average methane concentrations since about 1985 to present. And we can see this huge increase. And also in the middle, somewhere around 2000 to 2007, it stabilized a bit, but now it's increasing even more rapidly. And no one really knows exactly why it stabilized or why it's increasing so much now. So let's talk about the sources of methane. So where is it coming from? Where does it go? This is all explained by the methane budget. What it means is, what is the journey of methane molecules through the atmosphere since they are emitted until they are removed? So here we can see there are two main sources of methane. We have the man-made one, anthropogenic, or the natural sources. And we are, of course, most interested in the man-made sources, because those are the ones we can reduce. So the main ones are, of course, fossil fuel production and use, so oil and gas, and agriculture and waste. So, for example, landfills are a massive source of methane, and so are cows, as everybody knows. But actually, it's not their farts. It's mostly in their burps, which is this misconception that there is about cows and methane. So I want to show you also this really interesting plot, which is from a recent study, looking at the emissions, the methane emissions divided by sector, and also the potential for mitigation of the emissions. So if you see the circle, there are three layers. The outermost layer is the part of the emissions that are economically feasible to mitigate, and so it's essentially either quite cheap or not cost. The middle layer is the one that is technically feasible, and then the innermost layer is the rest. So I want to bring your attention to the oil and gas industry, which has this huge potential to reduce emissions at almost no cost. And the thing is, all the emitted methane by the oil and gas industry is actually income that is lost, because they're contributing to climate change, but also they're losing on that wasted gas. So this is what we are focusing on in our group with this work. So how do we actually measure methane? There are several ways to do it. You can have in situ instruments which measure the air around them. These are not very practical to scale at a global scale, because they're only measuring one point. But with remote sensing, we can measure large areas. So we can have an instrument in an aircraft or in spacecraft. And the good thing about spacecraft is that you can cover the whole Earth. So how do we measure from spacecraft? So we have the sun here at the top, and we have the Earth with the atmosphere. In reality, it's much thinner. And then we have our spacecraft. So the solar radiation travels to the Earth through the atmosphere, and it gets reflected, and then we detect it with our satellite. And we use what is called absorption spectroscopy, which looks at how much sunlight has been absorbed by the trace gas. And we can do this because each molecule has a very specific and unique spectral fingerprint. So it's a very unique way to absorb light. And this is why we can then work out how much of the gas was present at the time. So this is how methane absorbs light. So you see this gray line is how it absorbs light in the shortwave infrared part of the spectrum. And the thing is, with instruments, we can't really see so much detail, and it all depends on technical specifications. But for example, this red line shows an example of how an instrument might see the methane signal. So this brings me to the next point about satellite capabilities. So we have very different capabilities depending on the technical specifications of the instruments. And so one really important parameter is the spatial resolution. So this is how much detail you can see of, for example, this methane plume I have here, which I have simulated, corresponds to this point source marked here with the star. If we have an instrument with, say, 2 meters spatial resolution, then we may see something like this. And as the resolution degrades, then you see that we can see less and less detail. It's a little bit like when you have a pixelated picture. So another really important parameter is the noisiness. This is how your ability to distinguish the methane from the background noise. So in here we have 2 examples of different levels of noise, and you can see the noisiest one is the one at the bottom, and you have trouble distinguishing the methane from the one at the top. And then other things are really important also is the coverage. Does it cover the whole world or just a small area? And the temporal resolution. Do you have one measurement per day or multiple measurements? So I want to show you this really cool example of a methane leak, which was actually discovered from space. So there was this group of scientists that were looking at emissions from a volcano, and then they came across this massive methane release, and so they were not expecting this. They even thought it was just some noise, but it turned out to be a massive methane leak, which in fact was equivalent to the fumes of 1 million cars. And this was from an oil and gas field in Turkmenistan. And the good thing about using this sort of measurements is that you can act on it. So via diplomatic ways, they contacted the facility and they actually fixed the leak. So you can see in this plot at the bottom, there's a time series with the concentration of this plume. And then eventually you see a massive gap, which is where they fixed it. But then a few months later, it just started to leak again, which just shows you how important it is to do continuous monitoring. So now I want to show you some of our work with methane observations. So we use this satellite, which is called WorldView 3. It's a commercial satellite, and in fact, some of the images that it collects are used by Google and Bing Maps that a lot of people have on their phones. And the thing is, it's got the best spatial resolution that is currently available for methane. But the problem is that this satellite wasn't actually designed to measure methane, so it's got some limitations. The biggest limitation here is the spectral resolution. So in this plot on the left, you have, again, the methane signature. And then this is actually what the satellite can see. So only 4 blocks, which are all average. So it's only really 4 points of information here. So I'll show you a couple of case studies. This is the first one. It's from the US. This Alyssa Canyon, where there was a massive gas leak starting in 2015, which lasted for about 4 months. And there was so much methane released that it actually doubled the emissions for the whole Los Angeles basin for that year. And the problem was that there was this well that failed, and then there was massive amounts of methane being released. There was about 100,000 tons in total. So this leak we can see from space, and you have the example on the right. This is from data from WorldView 3 satellite. We've calculated the methane and plotted it here. You can see the plume. So in this video, you can see the leak as it was recorded with a thermal infrared camera. And it's really something. I think it was one of the biggest leaks in history. So The second case study I wanted to show you is from an oil and gas facility in the Middle East. So really with this satellite, we just wanted to see what can we detect, because, you know, I said it wasn't really designed for methane. So we've got this facility here. You can see these flames correspond to flaring, which is what they do to burn off the excess gas or for safety reasons. And this is what we get with our algorithm. This is the methane enhancement over the background. And it is not ideal, you see, because we have some surface artifacts. Then we found some problems with saturation of the detectors because of the flames. That was an interesting finding. But then we actually saw 2 real plumes of methane that you can see here. And let's have a closer look at these 2 plumes. So this, we can tell they're real because they follow in the wind direction, and they have the shape of plumes. And also, yeah, they don't match any surface features. So we're fairly confident about this. And you can see, you can identify the emission point sources from here. And the really cool thing is that then from this is only a snapshot, then you can actually quantify the methane that was emitted and calculate an emission rate. To do this, we take all of these pixels and we add them together. That's how much methane there is. And then we do some calculations with the wind speed. So this is just an example of the capabilities that we have with this satellite instrument. Of course, nothing is perfect, but the really good news here is that imagine what we can do with that all around the world. We can get to really remote places. And we, like in the example I showed you before, we can then sometimes discover new leaks that nobody knew about and fix them. And the thing is, there's a small number of super emitters that actually account for quite a lot of the emissions. And so it's really important to do this monitoring. And because methane, as I said, has a short lifetime in the atmosphere, but such a great warming potential, then if we can fix them quickly, then that's a lot that we can achieve quite fast. So this is my last slide. I want to give you some good news. The good news is we have all of these capabilities, but actually from about 2021, so this year and next year, we're going to start to get many more new satellites. So in this plot, you can see all the different satellites that are currently available or upcoming, and they are divided into different categories depending on their capabilities, such as the spatial resolution and the spectral resolution. But the main take-home message from here is that we have loads more coming. And so with that, I want to summarize this talk for you. So just to remind you, the methane is a really potent greenhouse gas. It's the second most important one and causes global warming and climate change. And actually most of it is emitted by us. Then that a small number of super emitters actually contributes to quite a lot of the emissions. And if we can act quickly, detect them and fix them, we can achieve quite a lot quite quickly. And finally, that satellite instruments are a really good tool to find these leaks around the world. And soon we will have loads more in space. So with that, thank you. I thank you very much for your attention. And yeah, happy to answer any questions that you have.
Thank you very much. That was a brilliant presentation, Cristina. And I've seen so many questions pop up in the comment section, again, wherever it is, somewhere on this screen. But before we switch over to the Q&A panel discussion where we'll start answering those, I'm going to sneak in again selfishly. So if methane's so awful for the environment as a greenhouse gas, what can I do in my day-to-day life to limit its impact? What can I do to help?
Well, you see, one of the big emitters of methane is, cattle, cows, as people know. So really reducing, for example, reducing how much meat you eat, it can go quite a long way. And it's not that one person does it perfectly, but everybody together reducing, for example, the amount of meat, then can go quite a long way. So that's one of the ways. This, of course, the landfills are really a big problem. So yeah, but that's a little bit tricky. But yeah, for example, food waste. There's a lot of food waste that ends up in landfill and then producing a lot of methane. So, like to summarize, maybe reduce your meat consumption and waste less food. just a couple of ideas.
So what we've been told for the last 5 years. That's brilliant. Thank you very much. So I think it is time to move on to the second part of our show, which is the panel discussion, where we answer all of your questions that have been rolling in about the environment, past, present, and future. So just hunting through the comment section, looking for our first question, which will hopefully flash up somewhere around me in a moment, which comes from Hannah Sellers. How can we address people's concerns about rewilding, particularly with large predators? I guess that comes to you, Pil.
Yeah, that's a good question. Really, really relevant that like when we do these conservation efforts, that people feel safe. But I think it's also really a question that we ask a lot in this part of the world where we are in Northwestern Europe, because we're not used to large predators anymore, really, right? So in India, they see like around 80 kills from tigers every year, and they accept that. So clearly, like, there's a tolerance to large predators other places in the world. So like maybe it's a question about like that we haven't seen them around for a really long time. We don't know why they are important anymore. So that I think matters really a lot. But also I think rewilding should be seen as something that is scaled really, so closer to urban areas. Maybe don't get the full rewilding projects going on there, but do the minor ones, and then further away from cities, we can scale them really up and have some of the larger species that will, of course, inflict human-wildlife conflicts.
Yeah, and I guess we don't see many mega herbivores or anything like that walking through our cities on a day-to-day basis. So hopefully, whatever we introduce wherever will stay away and eat what's natural to it. Or well, I suppose humans might be, but I imagine they won't be. I guess.
We'll see.
So next question comes from Phil Bell Young. As far as reducing methane, in your opinion, would be the most effective way to instantly or quickly reduce methane levels? Because it's for you, Cristina. Maybe a bit more other than diet.
Yeah, well, of course, the oil and gas industry is, as I said, quite one of the biggest emitters, and of course, a lot of it is caused by maybe failure of the facilities, things like that, or like the Leicester Canyon example I said. So this is quite a lot of methane being pumped into the atmosphere. So really trying to address those, and as we've seen with this plot, is like the biggest bang for the buck, really, to address these, because it's both economically feasible and quite a large proportion of the methane budget.
So is that a case of me switching energy providers, writing to my MP? How do you feel we can push on to make that change?
Yeah, that's a tricky one, because at an individual level, really, there's not much maybe you personally can do about, for example, failures in some oil and gas facilities. But definitely, I think one thing I would say is people should inform themselves. There's still quite a lot of lack of awareness about the whole climate change thing and where the emissions are coming from. And so, yeah, the diet is a big one. And of course, we eventually will have to move away from fossil fuels. So yeah, it's a tricky one, but definitely, as I said, food waste, diet, those two things are quite important.
Yeah, and I like that. Just be mindful and prepare for when you do have the power to make decisions. And that's a really important take home. Thank you. Ed Thomas, what are some other examples of keystone species from other environments, both past and present? I'll let you go first, Pil. I guess in my background, I've got a little bit to add here.
In addition to beavers and the bison, well, I think I showed, or I hope I showed, quite a lot of species that could be potential species for reintroduction. So, of course, here in the British Isles, like, you don't have large predators. So a keystone species would really be like a larger carnivore, right? Like the wolf, which has recolonized most parts of Europe. But there's a little barrier with the channel south of England, right? I mean, you have already come far with the beaver projects. It's been a trial for a long time. So, like, maybe people get more and more tolerant to these things. So we might see that even wolves in the future in the UK. Other keystone species could be some a moose, for example, which is a really good species for some of the wetlands, bogs, and so, and that might be interesting for many of the bogs or wetlands that you have here in the UK. So that was a couple of examples.
Oh, thank you very much. And yeah, like I said, I guess this feels into my wheelhouse, working on fossils and the past. What I'd say is that a lot of things that we consider keystone species in the past are what we take for granted today. So, for example, the establishment of coral reefs, they weren't always there. They might have only evolved hundreds of millions of years ago, but they completely revolutionized how we see life today. And then even things like flora, so large trees, and say the evolution of like flowering plants and certain flowers in certain environments are integral. Oak trees is a big one for me. They underpin an awful lot of habitats, maybe more of a microhabitat, but yeah. And then even some invertebrates in the past, particularly hundreds and hundreds of millions of years ago, in this thing called the Cambrian explosion, there was a lot of invertebrate bits floating about, and they were the first active predators in a lot of ways. So they were chunk up things, and they, at that point in time, were the keystone species of their day.
Maybe we should explain what a keystone species is.
Maybe we should.
Yeah.
I'd like to think your talk had that covered, but I mean, you take it away. You're the expert.
Well, keystone species is really just a species that have a disproportionately large impact on the ecosystem in proportion to like how large it is or how many individuals there are. So it really just a species that have massive impact compared to how little or few they are.
Yeah, and that, like Pil says, that changes through whatever lens you look at it from, and we're all biased in what we consider to be a keystone species.
Absolutely.
What's the next question from Sue Davies? How worried are you about the ice sheet melting in Siberia? Has anyone calculated the volume that they may release? I guess that's something Cristina first, and then maybe we can all comment on.
Yeah, that's certainly something that is worrying. It's not really my area of expertise, but yeah, I know that there have been some studies to try to quantify maybe how much is stored underneath. But yeah, that's definitely worrying because, for example, in the Arctic, there's like this feedback where the temperature is rising more rapidly than in the rest of the world, and the ice melts, and then also there's less reflected sunlight, so it contributes more to the warming. So yes, that definitely, I'm quite worried myself.
Yeah. And yeah, just to add a little bit to Cristina before I throw it to Pil, that idea of reflection, so we call it an albedo effect, where, because obviously snow and ice is white is white because it reflects all colors of wavelengths of light, and therefore if you're reflecting all of the light, including UV and infrared, so infrared being heat, then you reduce the warming effect. You're cooling the Earth down by reflecting away the heat. Pil, how about you? Got any comments on the ice?
Oh wow, it's also not really my expertise, but I know there are hypotheses that actually rewilding might actually help in reducing the climate change in Siberia, and there are ongoing projects in Yakutia. As far as I remember, that's where it is, where they rewild and bring in lots of large herbivores. So it's going to be really interesting to follow these projects, and I know they are associated with research projects, so they are going to be studied.
That's really cool. So as you can see, it's all interlinked, environmental sciences, and that's why we'll talk to each other and have events like this. But what's the aim of the herbivores? What are they going to do that's hopefully going to lead to that cooling effect? Is it just reducing plant cover?
I think there are more hypotheses in play, and I haven't studied them in detail. So I think I would rather not answer the question and suggest people to look at the literature because it's like there's so many hypotheses in play, really.
Okay, lots to isolate and work on. It's a whole future career. And from Emma Dodd, can we utilize landfill methane in some way to prevent it from going into the atmosphere?
Yeah, again, this is not quite my expertise, but I think there's some way to capture the methane and reuse it. I don't know that much about it though, unfortunately.
Yeah, I suppose that's it's kind of like that industrial application element of it, because my instinctual response was burn it off and get rid, which is kind of a panic button answer, I guess, for the methane. So if there's any big industrial links out in the audience who wants to comment on how they're going to solve that, please chime in.
Yeah, because I think in some farms, actually, they try to do exactly this, to capture the emissions and try to use them for energy, which is quite a nice thing. But yeah, I couldn't tell you more details about how exactly they do that.
That's amazing, though. I'm glad to hear that someone's on the case already and working on a solution. Waiting on another question to pop up. If not,
I really recommend. Watching. There's quite a bunch of fantastic documentaries on this sort of thing, climate change. So I really recommend watching some of those, like Kiss the Ground is a good one, An Inconvenient Truth and An Inconvenient Sequel, and yeah, loads of them. So yeah.
And I guess that's go away and find them on the internet. I'm sure they're on a streaming platform, but we will not pick one to endorse and put our money on that. But I'm sure that there are.
Yeah, wonderful ones. And I think there's a key thing to talk about it to your friends, your family, raise awareness, because that's really needed. That's quite a good thing one can do as an individual.
Yeah, most definitely. Most definitely. Oh, another one from Phil Young. Are there ways of reducing methane in cattle, for example, by changing their diets?
Actually, this is a really good question, and yes, there is. So by feeding them slightly different diets, I think they can achieve like 30% reduction. Of course, this is an improvement, but it's not really a complete fix from what I know. But yeah, this is an interesting one. I think feeding them something like seaweed. But yeah, this is also in one of the documentaries. If you want to learn more about it, it's really interesting.
That's quite interesting. I wonder if it's to do with like a grass versus other type of plant-based diets, because for those out there who don't know, not all plants do photosynthesis. their kind of energy making mechanism in exactly the same way, and it leads to lots of different byproducts. So I guess it might have something to do with that, but I'm not willing to bet on it, but I'd have a stab. I know this builds into something that I think Ed Thomas asked in the questions that I saw earlier, which was to do with the idea of carbon capture as a result of methane, and Pil, you might want to comment on this in terms of ecosystem services and how we might go about promoting that idea of taking carbon out of the environment or sequestering it.
I'm not sure I really know what to say about that, because haven't looked into carbon sequestering myself. So maybe someone out there might know more about it than I do.
May I just jump in on this one? I think, yeah, there are some methods to capture carbon, but really the best carbon sequestration that we have is, trees. And so what we should be doing is less deforestation and planting more trees. So this is really our biggest way to sequester carbon. But yeah, there are some ways out there. I'm not sure how economically feasible they are or how scalable, probably not that much. But yeah, again, not my area of expertise here.
Yeah, I had an interesting conversation recently in terms of close to home. I know we're virtual, but at the University of Leicester, there's the grounds team are actually doing some quite groundbreaking research in terms of cataloguing all of the plants that they have on university-owned campuses or buildings or parks or whatever. And there's something like 6,000 plus trees, which is just a ridiculous amount of trees. But they're managing to measure the amount of carbon in each type of species at different ages, and then work out what their carbon budget is in a bit of an aim to try and make the universities go carbon neutral and then negative, which is a really cool project to hear about, which I'd like to just, throw a little bit of a light on, and hopefully some inspiration for other organisations to get involved with. I suppose is there time for another question, if we have one? How much government support is Rewilding getting? Does it seem to be a priority of their climate policy? Thanks, Sue Davis.
Oh yeah, that's a really good question. I wish I knew the answer really. I think it's not settled yet. At least in the EU, it's not really being supported with the current the current common agricultural policies. But I mean, now you are free of EU, so you can kind of make your own system, really. And I know that the Neb estate, at least down in Sussex, the Rewilding project down there, they have been quite successful in getting support for some of the efforts down there, fitting them under traditional cap schemes. But I know they are working on, together with the government and other people engaged in this, to actually have schemes for the future that support more rewilding related efforts. And it would really make sense. I mean, if you have beavers on your land and they reduce the flood risk for the downstream areas, well, you are really giving something back to the society, right? So I think, that could easily be subsidized. Oh, that would make sense, at least. Yeah.
Yeah, I guess that's a comment on how science works in general. There's that idea of things are done privately or through research funding beforehand, before governments generally start pumping cash in. And I guess that's where events like this are amazing, because it means that you can all hear about it, hear about the amazing work that people like Pil and Cristina are doing, and then, not necessarily apply pressure, but talk about it, get it out there in the open, and start the conversations around it. I'm a little bit conscious that we've just clocked on to the 1 hour mark, which is when we said we'd all send you off to the next Pint of Science show. So I'd just like to take this moment to say thank you very much for all of you for coming, lending your support, hearing about these amazing programs that people are doing all over the world, all over the country, and a lot closer to home than you often think. And finally, say thank you very much to you for joining us, and good night.